The changes in machine vision the last 10, 20 years, I'd say that there's two big waves. The first one is skill level. It wasn't even about vision, it wasn't about machines. It was like a series of clever tricks. So count the pixels from one edge, go to the next edge, find a circle, etc. And that was like a really special person that could do that.
The technology was presented in a much more raw form, where you had to write software programs, often from scratch, to tie together different libraries of capabilities.
And you would just source that literally whenever, wherever. You didn't have any shop to go to. You just had to figure it out. You wanted to do it again, you had to start over again. What's changed in the productization is you started having people integrate more and more things. Software integrating more and more different libraries, capabilities, tools, and then eventually integrating the camera, liquid lenses, things that make the camera do everything itself.
It's simply easier to use, which means you can apply it to more applications. And as a result, the return on that investment arrives much, much faster.
And then the second enormous wave that's more recent was AI. Of all places where AI is useful, machine vision is definitely at the top. AI made it possible to go from solving a bunch of clever tricks to just asking a machine to do it.
So in the past, setting up a vision task was highly programmatic. It was very powerful and accurate, but quite complex and required very specific knowledge. The advent of AI and industrial machine vision has been taking a lot of that complexity away, where what was programming a vision job is now training a vision algorithm by example.
You have an infinity of rules. AI just comes up with it. But AI can come up with rules that are a lot more intricate than what humans do. They don't have to be as simple, they can be very granular. And so what it does is that the AI can have several rules for if there's more light, less light. And what it does to the user is that you don't have to care about a lot of things that you used to have to care about.
Using AI vision tools, you can train by example. And training by example is no more difficult than showing good examples and bad examples. Behind the scenes, the system is building a model and training itself so that when it's running, it can automatically determine those good and bad samples.
The biggest change in data collection is that it became cheap, really, really, really cheap. In a world where we had to offload large pictures over, sub-gigabit Ethernet networks, now we've got a world in which offload is trivial, storage is dirt cheap, and so now we've got all this data that all companies can keep. They can go back to see if something broke in the field, but they can also use it to train their machines better. Now, in a world where we were hunting for images of a bad example, where you would have to actually run the production sort of without a seatbelt, right? Like without having seen what a defect looks like. Now you've got all these other examples in the field that can show you what a somewhat similar defect can look like, because people have been storing all these images everywhere.
And so if you think about where the industry has come over the last 10 years, from what was a lot of complexity and required a lot of expertise to something that can realistically be designed and deployed with much less skill, I think has given us the ability to think more creatively and more ambitiously about how machine vision can be deployed in factories around the world.